Okay, this is the last example. Okay, again, this is a maxima minima problem. Now, what is the variables that are related here? Okay, you will notice that there is a parallelogram here. PQRS is a parallelogram. Okay, X and Y are points such that PXRY is a rectangle, and they give you these two lengths, 30 cm by 20 cm here. This is not the perpendicular height, okay, and the angle here. So what are related? Okay, what are related? Okay, you got to find the area. Okay, here you will notice that if you vary the angle theta, right? Okay, what will change is that Py and Sy will change. If I were to increase the value of theta between this range, from 0 to pi over 2 or 90 degrees, let's say I change theta to be larger, okay, what happens is that my area of this parallelogram will be varied, okay. As theta varied, the shape of the parallelogram will vary, therefore the area of the parallelogram will vary, okay. How does it vary? Whether it is increasing or decreasing, or at one point increasing and another part is decreasing, it depends really on the formula, okay. Now, how to show that this is now remember that this question is very similar to one that you have done, okay. If you take note, this is similar to your R formula, okay. There was this problem sum and then you got to convert into the R formula. Basically it's about the same, okay. Now in this triangle, let's study this triangle. Let's study this triangle, this one, okay. PSY. Now because why we need to study this, because if I want to find the area, right, I need to find the base times height. This is the base, SR. The height of the parallelogram will be PY. So if I want to find the area, right, okay, please take note, this is the what I need to actually put up. This is the base and this is the height, okay. And the base and the height will vary according to theta, okay. And if you take note, right, I can say that Py over 20 in this triangle, right, will be equals to sine theta. Therefore Py will be 20 sine theta. And in a similar manner, I can say that Sy over 20 will be cos theta. So Sy will be 20 times of cos theta. Okay, remember this. Remember this. Okay, to find the area, this is quite simple, right? You actually know that it got to be this SR times Py, SR times Py. Now SR, right, is equals to Sy times YR plus YR, sorry, and then times Py. Now Sy is here. This is 20 cosine theta. Now YR is actually equal to 30. This is opposite sides of a rectangle, so the length of opposite sides should be equal, and Py is actually 20 sine theta. You're going to convert this, okay, into this. Okay, how you go about doing that? Okay. Okay. I can take out 10 here. This is 2 cosine theta plus 3. This is 20. If you look carefully, right, this is sine theta. And if I were to rearrange, this is 10 times 20, this is 200 sine theta. Okay, if I were to open a bracket here, I can rearrange this one, 3 plus 2 cosine theta. That's it. I've shown. Okay, this is my A. It is wise to actually put all this in here. Now the reason why I do this is because sometimes you put just A here, right? You put equal, and then when you do, right, you forgot that this is actually your A that you found. Okay, so it is it is good actually to put all here to be A. Okay, now after that you have to find dA d theta. Okay, 200 is basically a factor, just a factor. Okay, dA d theta, sine theta times 3 plus 2 cosine theta. Now, this is a product. I can product this first. I will have two terms, and then I can actually differentiate separately. Or I can don't product this. I use the product rule to do this. I choose the later. I want to use by the product rule. So I take the first function. I use a bracket, and then I differentiate this one. This is 2 cosine theta, so I have minus 2 sine theta. And then I take the second function and I differentiate sine theta, I get cosine theta. Okay. Now I'm going to expand. This is just some manipulation. Okay, this is going to get 3 cosine theta plus 2 cosine squared theta. I want to be in this to get this right. Okay, basically this is in like a quadratic equation involving cosine theta, and what I noticed that is sine square. So I know that I can actually change this to 1 minus cosine square theta plus 3 cosine theta plus 2 cosine square theta, and this is going to be plus 2 cosine square plus 2 here. So this is going to be 2 plus 2 will be 4 cosine square theta, and then plus 3 cosine theta, and this is going to be minus 2, and I've shown again. Okay, can you confirm? Now, and then you got to find, okay, the stationary value of A. Find the theta for which A is a stationary value. Okay, so for A stationary, for A to be stationary, okay, dA d theta must be equals to 0. Okay, so if I put this to 0, so I have 200, okay, 4 cosine square theta plus 3 cosine theta minus 2 equals to 0. 200 divide, I have, let's say I put 4a square plus 3a minus 2 equals to 0. I will do a rough check. I realize that the discriminant is not a perfect square. This is 9. Okay, the discriminant, right, is going to be 3 square minus 4 minus 2, and I will get 9 plus 32. This is 41. This is cannot be square root. Am I right? So the A, I have to use the formula. Okay, minus 3 plus minus, of course this is the discriminant, right? 41 over 2 times 4. Okay, so my cosine theta is minus 3 plus minus root 41 over 8. Okay, now there's more space. Okay, again, cosine theta is equals to minus 3 plus minus 41 over 8. Okay, now I will have if I just check the value, okay, -3, okay, plus square root 41, okay, divided by 8, I will have cosine theta is 0.42539, 42539, or okay, -3, negative square root 41, okay, divided by 8. Now this is -1 point. So this one is actually rejected, am I right? Okay, so I only have to deal with cosine theta is 0.42539. Now I know from the problem sum, right? Okay, there is a restriction on theta, 0 to pi over 2. That means it's the first quadrant, right? So theta, okay, I need to give the answer in radian, okay? So inverse cosine 0.42539. Okay, I'm going to get 1.1314. Theta will be 1.13 radian, 3SF. Okay, now I need to check whether this, if you look at the question, right? Okay, they ask you determine whether this vector will make A the maximum or B A a minimum. Okay, now now I look at my dA d theta. Okay, again, this is my dA d theta. This is going to be a hassle, okay, for me to differentiate. Okay, not so I'm going to use the first derivative test. Okay, now I write down my dA d theta. Okay, you try to do, okay, 200 4 cosine square theta minus 3 cosine theta plus, sorry, okay, minus 2. Now remember, like that. Okay, this is theta 1.13, 1.11, 1.15, can dA d theta, this must be 0 definitely. And then I check, okay, make sure your mode is correct. It should be in radian. So you do this, okay, 4 times cosine 1.11, okay, cosine 1.11, and you do this, you will get the value whether A is minimum or maximum. Okay, thank you very much.